In this lesson, I'm going to discuss vectors. Vectors acts like a array which can hold multiple items. They are basically one-dimensional array and they can carry numeric, character, logical and etc. sort of values. We can create a vector with the help of combine function. Let's create a vector of some numbers with the help of combine function. And here is the vector, and let's see the items also. And when we execute it, it takes time for the first time. And it's been executed now, and it holds 5 elements of numeric type. We can create vectors of numeric as I discussed, and we can, let's suppose this is the fruit prices, and we can see the values also. And similarly, we can also create a vector of character type. Let's suppose it is a vector that holds fruit names. As you can see, I have created a vector of 5 fruits, and when we execute it, it returns us the 5 fruit names. And we can also create vector that holds boolean values. Let's execute it, and you can see we are getting the vector holding 2 logical values. And we can also create a vector which holds numbers in continuation order. For example, 1, 9 and 10. And let's see the items. And you can see that we have got this vector in continuation order. So this is one way of creating vector of this type. When we know that we have to create vector that starts from number 1 till number 10, then we can create such ranges with the help of colon notation. For example, I have created the vector of first 10 numbers, so I need to define the start point colon the end point. So when you define the start and end point, they are inclusive. 1 as well as 10 is inclusive within the range. Let's execute it, and we are getting the same result. We can also start from negative ranges to the positive range. So now we are going to get vector starting from -4 till +10. We can also reverse the range. It can be +10 to -6. And we are getting the start value as 10, as we defined the start value 10, and the end point is -6. So we are getting values from +10 to -6. Now if you are interested to know how many elements are there in this vector, you can make use of length function, and to this pass the vector name, and it returns us that there are 17 elements in this particular vector, and that is perfectly fine. Now let's understand how we can name vectors. Previously I defined 2 vectors. First one is the prices of fruits, and the second one is fruits. Now I'm going to copy these 2 vectors as well as the fruits. Now we have got these 2 vectors. The first one defines the fruit prices of these fruits, right? And the second one is the fruit names. So I'm going to give it a name, fruit names. So now we have got these 2 vectors. Now I want to give it a name. So remember that we have these 2 vectors, and we can name the vectors in 2 ways. The first method is with the help of names function, and to this I'm going to pass the prices of fruits to which I wish to assign names, and the names are given as fruit names. and in next line I'm going to print the fruit prices. Let's execute it, and you can see that we have got every price got assigned with particular name. So mango is assigned to 20, apple is assigned to 200, and so on. The other way is to assign the names to the prices with the help of equals to sign. You need to define the name and then equals to sign, and then apple equals to sign. Then we have got pineapple equals to sign, and then we have got grapes and kiwi. Previously we defined actually prices of 6 fruits, and you can see that we have got 6 fruits, whereas we had only 5 fruit names. So the last fruit price has been assigned the blank value, so there is no name for that particular fruit, right? The first one is mango, then apple, pineapple, kiwi, and you can see the last one has been assigned 6, right? So always keep in you need to be very careful while defining the names to the vectors. So this is the reason I have removed the last item in this particular case. So let's execute it, and you can see we have got 5 names assigned to the 5 fruit prices. The result is all same. Now let's understand how we can perform arithmetic operations on vectors. I'm going to create 2 vectors, n1 which holds values from 1 to 9 and n2 that holds values from 11 to 20. Let's print their values. You can see that we have got 2 vectors now. They can be any number, right? I have just taken one range and assigned those values to these vectors. In order to know the length of these vectors, you can make use of length function. So the first vector has 9 elements and the second one has 10 elements. So I'm going to replace it to 10. So in order to perform the arithmetic operation, what I'm going to do is I'm going to add these 2 vectors. Now you can see the first vector has values from 1 to 10 and the second one has values 11 to 20. So when they got add up, the corresponding values of these 2 vectors got add up. 11 plus 1 turns 12, 2 plus 12 adds up to 14, and 10 plus 20 adds up to 30. Similarly, we can perform subtraction. So I'm subtracting n2 from n1. So I have written n minus n2. This means 1 minus 11 should return us minus 10. So the result is going to be negative 10 for all the cases, because the difference of all the corresponding element is 10. If you reverse this order, n2 minus n1, it will return you positive 10. Similarly, you can divide vector n2 via n1. You can multiply these 2 vectors and you can perform any other arithmetic operation. The only thing that you need to keep in mind is that the corresponding elements get that operation operated on. In this previous example, I discussed how the vectors of same lengths get arithmetic operation done, right? We have done the arithmetic operation on vectors that are of same length. Now I'm going to consider 2 vectors that have different lengths. The first vector is of size 10 and the second vector is of size 2. There are 2 elements in the second vector, whereas 10 elements in the first vector. So what happens if I try to perform addition or any arithmetic operation on such vectors? So you can see the first 2 elements of both the vectors got added up and returned 2 and 4. 1 plus 1 2, 2 plus 2 4. Now these 2 elements of the second vector adds up to the next 2 elements of the first vector and they return 4 and 6. Then they get adds up to the next 2 elements of the vector and they return 6 and 8, because 5 plus 1 6, 6 plus 2 8, and so on. Similarly, you can perform any other arithmetic operation. The methodology will remain same. Now in this case, we have vector n1 which is in multiple of vector 2. The length of the vector 1 is in multiple of vector 2. That means 5 into 2 returns 10. What if the first vector is not in multiple of second vector, and when we perform, let's suppose, addition operation, you will also get warning stating that the first vector is longer object and it does not have elements or the length in multiple of the shorter object. Then that is perfectly fine, because 4 into 2 is 8, 5 into 2 is 10, and 6 into 2 is 12. So this vector does not fall anywhere in multiple of the second vector. So in that case, we have one extra element which does not match up these 2 elements. So what happens in that case? The last element gets added to the first element of the second vector and the second element is ignored. So that's how you can perform arithmetic operation on 2 vectors when they are of same length and when they are not of same length. Now let's understand how we can perform comparison operations on 2 vectors. Now we have n1. Let's suppose n1 is 1 to 10 and n2 is 11 to 12 to 11 to 20, n1 and n2. Let's see the items. So you can see we have got these 2 vectors of length 10. I want to compare these 2 vectors. I wish to compare whether n1 is less than n2 or any other comparison, like whether n1 is equivalent to n2. So in order to perform comparison operation, we have comparison operators, that is less than. It compares the first vector is less than second one, greater than operator, less than equals to operator, greater than equals to operator, and equality check operator, and not equals to operator. Let's see how they function. I wish to check whether n1 is less than n2. Now over here, when I write this statement, it returns me the logical results, that is the Boolean result. It compares the corresponding elements. It checks whether 1 is less than 11, which is true. 2 is less than 12, it is again true. Likewise, all the elements of the first vector is less than the corresponding element of the second vector. Therefore, all the results are true. And when I check n1 is greater than n2, which is not correct, so the result is false for all the elements, because all the corresponding elements of the first vector are not greater than the elements of the second vector. Now I'm going to create a vector n1 with 5 hard-coded value. Let's suppose 1, 5, 10, 3, and 30. And second vector has values 1, 2, 10, and 1, 20. Let's see them and what happened. I wrote them wrong. It should be the left arrow sign, and let's execute it. Now we are getting the correct vector. Let's compare them now. I'm going to compare whether n1 is equals to n2. That means whether the first element of the first vector and first element of the second vector are equals to each other. If they are equal, the result should be true. Otherwise, it should be false. So when I execute this comparison test, it returns true for the first case, which is absolutely fine. 5 is not equals to 2, so it returned false. 10 and 10 are equals to each other, so the result is true. Likewise, you can perform not equals to comparison, which checks whether the corresponding element of the one vector is not equals to the corresponding element of the second vector. If they are not same, that means the result is true. If they are same, the result is false. Let's execute it. So the first element of both the vectors are same, so the result is false. We are testing that they should not be same. In first case, when we used equality operator, we wanted to check that they should be same. Now let's understand how we can select items from the vector. I'm going to create one vector n1 with items starting from 11 to 20. This means there are going to be 10 elements in this vector. To verify that, you can make use of length function, pass it your vector, and in next line I'm going to print this vector. So it says that there are 10 elements in this vector and the elements are provided over here. Now, in order to understand how to select items from the vector, you need to understand the indexes. The indexes in R programming starts from 1, not 0 like other programming languages. So the first element has index 1, the second one has index 2, third one has index 3, and so on. In order to fetch the first element from this vector, you need to pass the index 1 inside the square brackets. Let's suppose n1, and you are interested to fetch the first element, so you need to define index 1 and it returns 11. When you say that you are interested in element 10, that is the index 10 element, you need to pass that index, execute this statement, and it returns you 20. So in this way we can extract single element from the vector. What if you are interested to extract the first 3 elements or middle 4 elements or last 3 or 4 elements? How you can extract them? So in order to do so, we need to make use of colon notation within the square bracket. So let's suppose we want to extract first 3 elements. So the start point is 1, colon, the end point is 3. So it will start from index 1 till the index 3. Let's execute it, and it returns us 11 to 13. If you are interested in extracting the elements from index 4 to index 8, you need to define those indexes. The start one is 4 and the end is 8. Let's execute it. It returns us 14, 15 till 18. You can also extract particular elements out from this particular vector. Let's suppose you are interested only in the element 14 and 17 that are available in position 4 and position 7. So in that case, you will have to pass the elements element indexes inside the square bracket with the help of combine function. So you need to define over here that you are interested in index 4 as well as index 7. So when you execute it, it returns you element 14 as well as element 17, as they are on index 4 and 7 respectively. Now I'm going to create one more vector with days and prices of the product. So these prices, let's suppose these are the prices of a product on different days of the week. These prices are fluctuating. They are going very high and very low on different days of the week depending upon their demand, let's suppose. So I'm going to create named vector from these two vectors. So let's assign days to these prices. How we can do so? We will make use of names, and to prices we will assign days of the weeks. So we have got 7 values inside days and 7 values inside prices. And finally, let's see the items inside the vector. And you can see that we have got vector with the names assigned to the prices. Now let's suppose you are interested to know the price of the product on Tuesday. So what you will do in that case, you will pick up prices vector, and to this you will pass the day, which is Tuesday. Let's execute it, and it is going to return you price on Tuesday. Let's suppose you are interested in Thursday now. You will pass the Thursday inside the square bracket, and it is going to return you 67 for that particular day. So this day is 4th day of the week, and you can also define it as 4th index of the item. You can also pass the numeric index, and it will return you the same value, which is Thursday has price 67 for that particular product. If you are interested in knowing the price of the product on Tuesday, Wednesday and Thursday, you can pass these days inside the square bracket as a with the help of combine function as a vector. So you need to define those days. And finally Thursday. So we are done. Let's execute it. So you can see it has returned us prices for these different days. Let's suppose you are not interested in Wednesday now. I'm going to remove it. Let's execute it, and it is going to return us the prices for Tuesday as well as on Thursday. You can also extract elements out of the vector with the help of a comparison operator. So once again, let's see what prices show us. It is a vector of 7 elements that defines prices on different days of the week. Now let's suppose you are interested only in prices that are above 30. So for that, what you will do, you will say, let's suppose prices above 30, but it is going to return you true or false values. When prices are below 30, that will be false. When prices are above 30, they will be true. But we are not getting the figures over here, and we are not interested in all the values of the week. We are just interested in values that are meeting our this comparison, this criteria. So how you will come out of this problem? To do so, I'm going to call prices, and within the square bracket I will write my condition, and it is going to return us the prices, the days when we had prices above 30. Now let's suppose you are interested in knowing the total price throughout the week. For that, you can make use of sum function. It will add up all the prices of the prices throughout the week and will give you the result. If you are interested in knowing the mean price, then you can make use of mean function. And if you are interested in knowing the median of the prices, you can make use of median function.